Hello everyone. Today we are going to take a look at the first part of chapter 23.1, part 1, which is on series circuits. So our learning targets today to compare series and simple circuits and apply Ohm's law to series circuits. And specifically what we are looking for is the similarities and differences between simple and series circuits, and how Ohm's law functions in a series circuit. So as always, let's start with a little bit of review just to get our brains engaged. So, what is electric current? Can you answer this one without me? Good for you. Current is the movement of electrons in a path, right? Sometimes we talk about it as the flow of charged particles. And we know that those charged particles are electrons. All right, so what about an electric circuit then? If the current is the movement of the electrons, right, the charged particles, what is an electric circuit? So an electric circuit is when the current does work, right? We've talked about that before. It lights up a light, it turns a motor, it makes a fan work, it charges your phone, any of those things. So when that current does work. And Ohm's law, what's Ohm's law? So remember that Ohm's law relates current, I stands for current, to the voltage and the resistance. So I equals V over R. And we know that I is current. We measure current in amperes. We know that V is voltage. We measure voltage in volts. And we know that R is resistance. And we measure resistance in ohms. Okay? Last review question. What are the three components or three parts of a simple circuit? Do you remember? A simple circuit has one source of electrons, right? We usually use a battery. It has one path for the electrons to travel on. They don't have a choice. They all have to go the same way. And it has one, that's a zero, that's an O, device that's going to use the current. And when we were in class, we built our simple circuits with light bulbs. We also added a switch to our simple circuits. Remember, we said a switch does not change the type of circuit it is because the switch doesn't really do anything, right? It's just there to turn it on or turn it off. All right, so there's our review material. So our first essential question, what are the similarities and differences between a simple and a series circuit? So on the left, there's a diagram of a simple circuit, and we can see there is one battery, one device. Here's my one path. This happens to have a switch in it, but we said that doesn't really change the type of circuit that it is. All right, so there's my simple circuit. All right, here's my series circuit. So take a look and see what's different between the simple one that we just looked at and the series circuit. So I'm going to give you a minute to think about that. What's different between this series circuit and that simple circuit? All right, have you thought about it? All right, actually, you know what? It looks like I wrote the questions in the wrong order. So we're going to start with what's the same. So what's the same between the simple circuit and the series circuit? Well, the first thing I see that's the same is that they both have one battery. So we're going to say one source. And the second thing I see that's the same is that there is only one path. Right? My simple circuit just has one choice for the electrons to move on, and so does my series circuit. So my series circuit, right, all the electrons have to flow in this same direction. Okay. I also see that both of these circuits have a switch, but we said that really doesn't make a difference, right? So we're not going to write that down. Yeah, that's about what I see. Okay, what do we see that's different? Well, the biggest thing I see that's different is that this simple circuit has one device and my series circuit has 3 devices. So that's what I see that's different. What's different? It has more than one device. Now, specifically, it has 3 devices, but you know that doesn't necessarily have to be true, right? It could have 12. Let's say if it's a string of Christmas lights, maybe it has 100, right, devices on it, or maybe it just has 2. Maybe it has a hairdryer and a curling iron or something like that, okay? So the only thing I'm going to point out to you that it was really hard for me to find a picture that would show this is that this one source doesn't necessarily have to be the same. So it could be more than one source, but this one path idea, that's absolutely true. So we're going to say down here, 1 or more devices. Not devices, my bad. Sources. Okay? So a simple circuit has one source, one path, one device. A series circuit can have 1 or more sources, one path, 2 or more devices. Okay? So here's the first your turn, please. Write a sentence summarizing the difference between simple and series circuits. So shut the recording off. Go ahead, take a minute, write your sentence, and then turn it back on. All right. So let's take a look at essential question number 2. How does Ohm's law function in a series circuit? So in order to talk about Ohm's law, right, because Ohm's law includes the resistance, and obviously we've changed the number of resistors in our circuit, the first thing we have to do is deal with the fact that we have now more than one resistor. So we're going to have this new term here, the equivalent resistance. That's the same as saying the total resistance. And the way we find total resistance is that we add all the resistors in the circuit. Okay, so it's very simple. So here's my formula. R sub T, so that means total, that's what the T stands for, total resistance is the sum of all the resistors. So R1 plus R2 plus R3 plus, and then we put ... because we really don't know how many resistors there are going to be, right, until we see the circuit. So for my picture up here of my series circuit, there's A, B, and C, so I would have resistors A plus B plus C. But I could have, again, 100 resistors if it's a string of Christmas lights, or maybe I just have 2 resistors. So we have to kind of leave ourselves some room here. R1 plus R2 plus R3 plus, if there's any more resistors. Okay? So how do we then find the current in a series circuit? So we're going to go back to Ohm's law, right? Ohm's law is all about finding current. So current is equal to the total voltage. So if I were to have more than one battery, I would add up the voltages from those batteries, and the total resistance. Okay, so we haven't really changed the formula, I equals V over R. We have just acknowledged that there could be 2 batteries or more. There could be 2 resistors or more. All right, so let's see how this plays out. So problem number 1 here says 2 25 ohm resistors are connected in series with a 120 volt source. So what are the important things here? I have 2 25 ohm resistors. It's a series circuit, and there's a 120 volt source. So I'm going to call this R1 is 25 ohms. R2 is 25 ohms. V is 120 volts, and I am also going to remind myself that this is a series circuit, okay? Next time we're going to do parallel circuits next week, and so that's going to be different. So the idea that we're paying attention to that it's a series, that's important. Okay, so part A says draw a diagram of the circuit. All right. So I have a 120 volt source. I'm going to go ahead and label it since I know how strong it is. I have 1, 2 resistors connected in series. We're going to call this one R1. We know that it's 25 ohms. We're going to call this one R2. We know that it's also 25 ohms. Okay, so there's part A. I drew my circuit. Part B says calculate the equivalent resistance. Equivalent is the same as the total resistance. So let's go ahead and calculate that. That's kind of a mess. There we go. So my equivalent or my total resistance is R1 plus R2 in this case. There's only 2 resistors. So this is going to be 25 plus 25, which is going to give me 50 ohms. Don't you like it when the math is easy? So do I. Okay, and then part C says calculate the total current in the circuit. So that means I'm going to use Ohm's law. Total voltage over total resistance. So I'm going to have 120 over 50, and that is going to give me a current of 2.4 amperes in my circuit. Okay? So, not too tricky. Here's your turn for you to practice. There is a circuit over there on the right, and that circuit is what you are going to use for all of these problems, A, B, C, D, and E. Okay? As always, if you have any questions, make sure you write them down, and we will be looking at these notes in class next time. Thanks so much. See you soon.